So, like all the security conference that we go through, like there's a lot of discussion on AI, but like my topic is a little different. It's quantum. So what's quantum? So Einstein told that quantum is a spooky action from a distance. That's the quantum physics. So I know Halloween is coming, so let's talk about some spooky story, how quantum can help us or how we will get quantum-safe world. So let's start with like, oh, by the way, I'm Ikhtear Bhuyan. I've been working on the security field. Currently, I'm working with IBM as a security architect. My primary focus on AI and quantum security. So when we are talking about any kind of security, so we need to talk that aspect, like okay, how that particular technology works. So there are a lot of research has been done on quantum computer, and it's coming. All the big vendor like Microsoft, Google, IBM, NVIDIA, everyone is investing on quantum. Why? Because okay, from CPU to GPU, there is a transition, and now from GPU, what next? So we need some more powerful computing compared to what the traditional computer can do. So, this system level, like, what's like quantum computing? Anybody in this audience have some experience with quantum computing or a little bit? Okay, or understand? Okay, that's fine. So there are like three major, I would say, properties of or principle of quantum computing that makes it totally different from the traditional computer. So that's superposition, entanglement, and we call it interference. So that makes it totally different because quantum computer don't follow the straightforward way that a traditional computing works. It actually takes in consideration of multiple different I would say result set and then zero into the correct one instead of 1 or 0. And how it has been like, we have seen that for like probably like the quantum research has been done for almost 10, 15 years. But now the industry is adopting quantum. For example, there are some quantum computing is being used on the real life. So for example, like the Vanguard, they actually partnered with IBM, and HSBC also partner, and they actually created their quantum-enabled algorithm for trading. So you can see that like the quantum computing is being used for very like complex mathematical problem solving and other like more complex thing, and that helps compared to the traditional computer because it can solve complex problem very quickly because of those three properties as I mentioned earlier. So, but the challenge is every time, like now we all talk about AI security. AI is like great. Like we saw like AI is being used on different organizations for productivity and other stuff. But every time in the technology world, we introduce a new technology, it comes with a different attack surface or a challenge or a risk. Cloud, all we got it. Okay, now cloud is being handled. Now AI come, and then, oh, there's so many talk, like prompt injection, evasion, other stuff. Now what quantum? What, like if in the near future, when the quantum come, what is that risk that we will be like seeing with when quantum computer will be available? For example, I cannot go to Best Buy and buy a quantum computer at this moment. It's not available at this moment. But when it is available, what are the different challenges? So if you, the main challenge that I would say for right now is harvest now, decrypt later. What does it mean? It means all the secret that you have at this moment, it will no longer be secret when quantum computer will be available. Okay, you can tell like how come. So there are, like, how do we protect our secret? The basic answer is we use encrypt our disk, and we use our PKI infrastructure, and this is how we transfer different data from from on-prem to cloud, from B2B, and all those different communication. Everything is encrypted. This is how we actually use secure our communication. And cryptography is the building block of all our digital world. You talk about your email, you talk about your HTTPS, SSLD, everything. So when I'm talking about that, hey, your secret will no longer be a secret, well, if it is not time sensitive, for example, I did purchase something from Walmart with a credit card, that credit card information went from the POS terminal to the payment server. And probably after 4 or 5 years, my credit card would be invalid because it will be expired. Every credit card has an expiry. So if that is not time sensitive, then probably you don't need to worry about your secret. However, your health record, your SIN number, and all those different things are stays for longer period of time. Like your passport information, those stays for longer period of time. And that secret need to be secure even when the quantum computing will be available. So when I told you, okay, the future is coming to steal your data, what does that mean? It's not a sci-fi movie thing. We are talking about when someone has a crypto-relevant quantum computing resource to use, then what will be the effect? So let's check about why I talked about, okay, harvest now, decrypt later. What's the strategy about it? So typically what we do in any enterprise or anywhere, we have some intellectual property, we have some PII data and other trade secret. We keep it in a secure vault or some places. And then what we do, we use some cryptographic algorithm, AES, RSA, or any other thing, then using some key and put it in a ciphertext. That works. And this has been working for decades. If we need that data, what we do, we decrypt it using the same key or depending on your PKI infrastructure, and then we get the data back. It's all working fine. But when the quantum computing will be available, at that time, what will happen? It can actually solve the complex mathematical problem that is underlying on those cryptographic algorithm. For example, AES, RSA, Diffie-Hellman, or bouncy castle, any kind of cryptographic algorithm you're talking about, those are really very complex math problem that is embedded so that you cannot decrypt those information from an encrypted information. So, but as I mentioned earlier, with using those quantum property, we can actually we can do those complex problem into a shorter period of time. So if we have a quantum computing right now, and then what we can do, we can actually take the encrypted information and we can decrypt it using some other algorithm like Grover or Shor algorithm. And that will actually disrupt the whole digital world. What will be the effect? Our payment gateway will be forged. Our digital secret will no longer be a secret, and that is what we need to prepare for. So, but the good part is quantum computer is not available or handy, and to the best of our knowledge, based on all the different research that has been done from academia and also from different enterprise, the crypto-relevant quantum computer probably coming maybe in next 4 to 5 years or 3 years. So that's a good part, right? So right now you do not need to worry about. You can like become, and you can think of after, you can wake up after 3, 4, 5 years and then say, okay, that when the crypto-relevant quantum computer will be available, we can think of that, the challenge that I'm talking about. However, what is harvest now and decrypt later? The bad guy, what can do? That basically for the, they're looking for some trade secret or intellectual property. They can sniff on the network, all those different public network, and they're trying to get those data. They can store it for some time as an encrypted form, and once the crypto-relevant quantum computer is available, they can use it and decrypt it and get those secrets out of your organization without knowing you that, okay, they has been actually taking all the secret. So when should we prepare for that particular thing to happen? So we call it Q-Day. So what is Q-Day? Unlike Y2K, who actually heard about that 2000, that okay, Y2K happened, and then all the computer will not work anymore. But these are the different things that can happen in the Q-Day. So as I mentioned, they can decrypt the payment industry, they can actually do the the power grid. As the power grid actually works with different kind of communicate with those different PLC, communicate with different kind of encryption algorithm, they can actually disrupt those communication too. So everything will be disrupted. So right now, for preparation for those particular Q-Day, what we can do, we can we need to mainly we need to prepare for, okay, where and how am I using those cryptography in my organization? That is important because that will actually help you to prepare for the future. Especially if you are a developer, if you are using, say for example, if you are a Java developer, you are using some GSCA library and other stuff, so you need to think of okay, what kind of cryptographic algorithm that I'm using on my code. Because that probably, when the application is being deployed in the enterprise, someone wrote those applications 5 years back. I don't know where it has been used, the cryptographic algorithm on the code itself. So those are the different things that you need to think of. And then also, how can we prepare for those particular, the encrypted information that we have at this moment in our enterprise? How can we actually secure it for the future-proof encryption? So that was another part of it. But when the Q-Day will happen, so so that we can think of that, okay, but when I was talking about those, okay, changing of application code, you are changing your PKI infrastructure, because if you think of where are those cryptographic is being used, it is being used everywhere. So it is not a single month of project, it's a multi-year project. So you need to think of your particular infrastructure depending on where are you working, what kind of business are you in, what are the different data that is your secret. You need to think of that aspect and you need to prepare for that. So as I mentioned earlier, okay, it will be disrupted, but why it will be disrupted? So basically there are two kind of cryptographic algorithm that we use nowadays. One is symmetric and one is asymmetric. The symmetric cryptographic algorithm, we use the same key, we encrypt those any piece of information, and for decryption we use the same key. typically like AES or other is most popular that we have been using. 256-bit is mostly, we are calling it more secure. In some application we use 128-bit, but 256 is more secure nowadays. And the other one is the asymmetric, where we use the public key, where we use the public key to encrypt, and only the people who has the private key, they can actually decrypt those things. So, and usually, like RSA is the most used encryption algorithm, and we use usually 1024-bit to 2048-bit of key to do that and decrypt, encryption. In the case of quantum computing, that what we are talking about, that okay, how it will affect our cryptographic algorithm. So basically, in the case of asymmetric key, we use a prime number of factorization. So for example, if I say, what are the 2 prime factor for number 35? It's very easy, 7 and 5. But if I say, what is the prime factorization of this one, you probably will spend entire life to do the factorization of this large number. In fact, this is this number. So Peter Shor and Grover, they created a certain algorithm way before, in 1980s actually. They created those algorithms that can actually do the factorization of those prime number. And if you run a Shor algorithm in a traditional computer right now, in theory, it will take almost 1 million years to decrypt those big 1024-bit of prime number to do the factorization problem. However, with the quantum computer, it is assumed that it will take only a few hours. So what we can do to prepare for the future? So many researchers and some industries been working on it, and finally, after 2.5 years of evaluation, National Institute of Standard and Technology, which is called by NIST, they published 4 cryptographic algorithms that is quantum relevant with what we call post-quantum cryptography. And IBM contributed 3 of them, and one of them has been contributed by an academic researcher, which was also hired by IBM. But these are the different algorithms that you need to use in order to secure your environment for post-quantum cryptography. And this is open source. But in order to be a happy ending, you need to implement those algorithms into your environment. Now, this is the challenge. Can you see where are those tool set is being used? It's too many places. It's not only one single place. So that is a big challenge to migrate from those encryption algorithms and become more quantum safe. So what you need to do, you need to be more crypto agile, I would say. So there is a term called crypto agility in the cryptography world. So basically it means that the ability to rapidly adopt cryptographic algorithm without disrupting your business in a short term. And how does it work? But in order to do it, you need 3 things to work together. You need your people, process, and technology work together in order to be agile on the cryptographic part. Why? As I mentioned in my previous slide, there's too many places that cryptography has been used, your SSLD and other part too. And main challenge is the lack of visibility, because as I mentioned, especially from the application development perspective, when all the application developer that they're using, you don't know where they has been used, because typically the SaaS solution that we have, like Fuser and other stuff, they can only do the vulnerability check, like WASP top 10 kind of thing. But they do not do the cryptographic relevant test and tell you, okay, these are the different places you actually use your cryptography in your application code. So what we need to do, this is the approach that we actually adopted inside IBM. So you discover all your cryptographic inventory and assess and check how do you comply with those different aspects of those cryptographic inventory. And then you need to protect and change it. So the way that it works is like, okay, fine, we first discover from a network side, from an application perspective, from my certificate perspective, from my private key infrastructure perspective. That's basically typically you can start with. And then for the assessment, you need to check, okay, what are the different cryptographic algorithms? Like still we can see that some of the organization, or some places, TLS 1.1 is being used instead of the recent TLS. And then you need to rotate those certificate and everything with the quantum relevant algorithm, or PQC, what we call. But the challenge is sometimes there are some legacy applications that we cannot change. What we can do in that case, we can use a crypto proxy. What it means, okay, the user is accessing in the browser, maybe Chrome or some other browser, they will be changing their with the cryptography, they will align with the cryptographic algorithm. However, the application falls under your part. So instead of having a crypto, sending everything into the regular cryptographic or SSLD in a regular way, what you can do actually, you can put a proxy in between the user and the application. So what will it do? It will use the post-quantum cryptographic algorithm between the user and the proxy, and on the right side, from proxy to the application, it can use the traditional or legacy encryption. But that is secure. Nobody can actually help, log into that part. So that's another approach you can follow whenever you don't have enough time to migrate everything to the post-quantum cryptographic algorithm, because it's complex. And the Canadian Center for Cybersecurity, they provided some guideline. There are actually two things that they mentioned about how you can be crypto agile. And also there's some guideline around from April 2026, you need to start your crypto inventory, because crypto inventory itself is a year-long project. So this information I just wanted to share with you. And one thing from a technology perspective, there are some technology available that you can actually do some CBOM, which is cryptographic bill of material. IBM has a product called IBM Quantum-Safe Explorer, where you can actually do the scanning of application and provide, okay, which line of code is used on those different cryptographic algorithm. Also, they have a cryptography manager. They can actually, it's not like replacing your Entrust or VeriSign or those CS certificate or anything. That actually they can actually assess, connect with different stuff. So you need to, that can help you to faster your migration process, and the proxy that can help to remediate the cryptographic proxy that I mentioned, like the place where you cannot use or change your application code because of the nature of the business that you have. You can use a crypto proxy that can help you not to bypass and be crypto agile. So that's what I just wanted to share with you folks, that you need to be prepared for the future, which is coming in the next few years, but you need to prepare now unless it is too late. Or there is another solution. If you have a time machine, you can, after 2 years, you can take the time machine, go back, and encrypt everything with the PQC algorithm that has been published by NIST. Thank you.
Thank you, Ikhtear. We have time for one question. Way in the back.
Hi, I've been around long enough that I remember when 56-bit BES was military-grade encryption. What makes this change of so different than all the other ones? Why is this one scarier than all those ones were?
So the question was, what makes this different than all the other ones, and why is it more scarier?
So as you can see, like, it's not so easy to change the whole cryptographic from your infrastructure perspective. So, and the research has been done a significant improvement on the quantum qubits. So it, like, when it will be handy, it will be very easy for the people to do any kind of data exposure. And as there's some other stuff is happening from the AI revolution, that data is very available at this moment from all those different part of the application and other stuff. So that is also another aspect of it, because your data is available to store right now. You can extract, you can ask some prompt and get some data, store it somewhere, and this is how you can actually get all those data in the somewhere, and then once it is available, you can just decrypt it from there.
But the same thing is true if I have data that's encrypted with 56-bit BES. I can go back now on a pocket calculator. The same, that's what I'm saying. I don't see how this is materially different than converting from DES to triple DES.
Yeah. Yeah, so Grover algorithm actually knocked out half of the AES, so that's why the symmetric key is not that much of affected. Mostly it is affected the asymmetric part of it. So like if you say, for example, if you're using 128-bit, if you change it to 256-bit, even if you run Grover using some crypto-relevant quantum computing, they can knock it out half, not the full. So you actually get like the same amount of security. But mostly you need to think of the asymmetric part of it.
All right. No, thank you very much. Thank you, Ikhtear. We're gonna.
I'm available. If you have any question, we can just.
Yeah, if there's any questions, Ikhtear will be in the hall. You can just approach and talk to him.